Hi, welcome to MathBit, and today we're going to do Laplace transformations, and we're going to do it using the table instead of first principles. So we're going to do it from A to E for this video, and we'll continue. I will do another video continuing with the problems. So without wasting time, let's do it. Uh, this one should be simple. f of f of t equals to sine 2t cos 2t. And remember, we are transforming f of t into f of s, right? So, so we have f of t, we need to transform it into f of s, but then we need to put it in a way that it can be useful for us to transform it to f of s. So in this format, it's not possible to do it. So we're going to use identities. So we're going to multiply that by 1, of which we didn't change anything, sine 2t cos 2t, and you'll be left with half sine 2t cos 2t. And this is an identity. This is an identity of sine 40. And this is still f of t, but we want f of s. So let's see. We're going to use rule number 7. And remember, it was sine 40. That means our a is 4. And if our a is 4, that's going to yield 4 all over sine squared plus 4 squared. And this should be easy. So we are introducing Laplace on both sides. So you can write it sine 40, and this is 4 all over sine squared plus 4 squared. And this is the final answer. Now let's do B. B also, it's not complicated. It's f of t equals to cos squared 3t. And we need to use identity also because we can transform it from f of t to f of s in this format. So we're going to use an identity of half 1 plus cos is going to double this angle, which is 60. They're equal. This is f of t. And now we introduce Laplace. So I'm just gonna write it on the left hand side only, and this is constant. And if we have a constant 1, let's see, it's going to be this one. We're going to use the first rule. It's going to be 1 over s plus, now we go to cos. Our a is 6 in this case, right? So that means it's going to our cos, excuse me, 16 is going to yield s over s squared plus our a is 6. So that means it's going to be 6 squared. So it's s all over s squared plus 6 squared. And this is your answer. for B. So let's do C, and I hope we are together up to this far. Our C is f of t equals to t e to the 2t sine 3t. So we need to find, let's go to our table and find ways we can solve that problem. Um, Let me wrap this, excuse me. So as you can see, we're going to use this one, and I'll show you why we're going to use that one. So let me write that rule here. So it says e to the s t f of t is going to yield f t minus c, right? And when you look, we have this one. So we can write it as uh, to e to the exponent of 2t t sine 3t, right? I hope we are together up to this far. So when you look, our c our c our c it's 2, and this will be our f of t from here, right? I hope we are together up to this far. But then if you don't understand, you can go back, can pause the video, and maybe see where um you can solve it, on your own, and see where you get stuck, because I've given you a clue up to this far. But then let's continue. So this will be f of t. It's going to be a f of t, but our c is 2, remember. So as you can see, in our final product, you don't have this thing. We don't have e to the c t. We only have f. We only have f of t minus c. But then our e, it's only guiding us in terms of our c, because of our c it's 2. So let's see. Our f of t, remember we said it's t sine 3t. So if we apply a Laplace on that, it's let's see, we are using this one. So as we can see, our a is 3. So the rule says it's 2a s all over s squared plus a squared all squared, right? But then here we so no, excuse me, it's supposed to be s. Yeah. So as you can see here, it's s, it's f of s minus c. So that means whenever we see s, we're going to substitute f of whenever we see s, we're going to substitute s minus c, and our c it's 2. So that means, remember, our a, it's 3, and this is our s, Remember, our s, we're substituting s minus c, but then our c is 2 all over s 2 squared plus squared. Our a is 3 and 3 squared is 9 all squared. So this should be your final answer. This is 6 s minus 2 and what's on the bottom. I hope this is clear so far. Let me try to repeat it again. We had let's see if we can change colors. We had this equation, right? And then this became our f of t, right? So that means if it's f of t, we are transforming it into f of s, right? Here it is. But then we don't want f of s, we want f of s, we want f of s minus c. But then our minus c is 2. Hence we substituted here. I hope it's clear now. So let's do the next one without wasting more time. Let me use the red one. F of t equals to t plus 3 union 7 t. So let's simplify this one. It's u, it's t minus 7. This one is f of t, still f of t. And as I said in the beginning of the video, you need to put it in a way that's going to be helpful to you. So I'm going to multiply this throughout. So it's going to be t u t minus 7 plus 3 u t minus 7. And when you look to your table, we are going to use where is it? We are going to use this one. It says t and f of t, where our n is 1, 2, 3. This thing is going to yield minus 1 to the n f n s. So that means if our n is 2, then that means here is going to be 2 and we're going to differentiate it twice. And if our n is 3, we're going to differentiate it 3 times. So on and so forth. So this is n, this is n. So from our problem, our n is 1. So let's make that clear. Our n is 1. So let's solve this one first and then we'll solve this one later. We are saying f of t, it's t u t minus 7 plus 3 u t minus 7. So to make the matter simple, let's make this thing, we're going to let this thing be g of t because it's a bit complicated. So I'm going to solve my g of t and I'm going to turn it into g of s. So this means there's remember my n is equals to 1. So this is my 1, and I have to find f of s. I have to find f of s, but then I need to differentiate it. So it's going to be ds Laplace of u t minus 7. I hope this is clear, and this one is minus 1. Um, so basically I'm solving what's inside. I'm looking for the Laplace of u t minus 7. Um, we're going to use, sorry, we're going to use this one. So in this case, it's u t minus 7. So that means our c it's minus 7. So basically is it's e to the negative 7 s. And we're going to differentiate what's inside. We're going to use chain rule, and I'm sure we are familiar with the chain rule method. So we are going to differentiate the top one. It's negative 7. Excuse me, it's negative 1 here. It's going to be negative 7 e to the negative 7 s. You multiply that with s minus you leave what's on the bottom as it is. You differentiate what's on the top, which is s. When you differentiate s, it's just 1. Going to leave it as it is. Then you square what's on the bottom. So that's basically chain rule. So multiply by negative 1, everything is going to change the sign. So here is the final answer. Right? But then remember, this one is only g of s. I'm looking for f of s. It's only this part. And this part, we are just going to use the very same thing. This is equals to 7e minus 7s multiplied by s plus e to the negative 7s all over s squared. Now, the answer to this is just 3. Remember, it's e to the negative 7s all over s. This is the final answer. So this is f of s. I hope this is clear so far. As I've broken down this problem on my f of t, and I made this g of s so that I can solve it because it's a bit complicated. And here's that final answer. And this one, it's just easy. We could use a table here, and then here it is, and then this is the final answer. This is f of s. So, and you can always go back. You can always go back to this, to why I'm doing this problem. And then let's do e. Let me change e. F of t equals to t squared u subscript 3 of t, and this, when you simplify it further, it's t squared u t minus 3. And then remember, we're still gonna use that thing because of t, so it's t and f of t, where n is 1, 2, 3, etc. This is going to yield an outcome of, let me double check. This, so it's going to yield an outcome of minus 1, and is n s. So in this case, our n is going to be 2. So, but then our f of t is this. So f of t is equals to, wait, no, our f of t, it's this. So our f of s, remember, is going to yield this outcome. It's minus 1 is squared. And now we are looking for f of s, but then we need to differentiate it twice. So it's d squared all over ds squared. But then we are looking for the Laplace first. Laplace of, I hope this is clear. This is the simplest I can put it, the simplest form. So this is just 1, so it's just going to wait to differentiate. And now I'm going to use 25. So it's e to the negative, now it's going to be 3s all over s. But I need to differentiate it twice. Let's differentiate it. Differentiate the top part, minus 3 e to the negative 3s. You multiply that with s minus e to the negative s, sorry, negative 3s. I'm going to differentiate the top, the bottom part, which is going to be 1, it's 1 here, all over s squared. But then I need to also differentiate that as well. That's why I put prime there. So let me simplify it further. It's negative 3 e to the negative 3s multiplied by s all over s squared minus e to the negative 3s all over s squared. And this is all prime. But then you could see that we have s here. So let me going to cancel. So let's differentiate the first one and the second one. And we're going to use a chain rule on each part. So it's negative 3. You multiply that with another negative 3 e to the 3s. You multiply that with s negative. You leave that as it is, e to the negative 3s. We differentiate. This is just s. I mean, it's just 1. So I'm not going to put it. I'm going to leave it as it is, and s squared. And then negative, it's this negative. I'm differentiating the second part. The second part is negative. Let me put brackets here. So it's negative 3 e to the negative 3 as you multiply that with what's on the bottom, it's x squared minus you leave first the top part and you differentiate the second part, which is 2s all over, you square that, which is going to be to the exponent of 4. So you can just leave it here, or you can simplify it even further. Actually, let me simplify it a bit. So this is going to be 9 e to the negative s, negative 3s, this is s, this is positive 3 e to the negative 3s, this is all over s squared. This minus is going to be positive because of this, so this is all positive, e to the negative 3s s squared plus e to the negative 3s multiplied by 2s all over s to the negative 4. So here is the final answer.